Hello everyone, I am Dr. G. Seshadri, working as a professor in Institute of Aeronautical Engineering, Hyderabad. Today I want to give a lecture presentation about DC motor numericals. This is fourth lecture regarding numericals. So course objectives, the students will try to learn the elementary, experimental and modeling skills for handling problems with electrical machines in the industries and domestic applications to excel in professional career. The operation of DC machines and its role in power transmission and distribution, the intuitive knowledge needed to test and analyze the performance leading to design of electric machines by conducting various tests and calculate the performance parameters. Coming to the outcomes, course outcomes, at the end of the course, students should be able to analyze the performance characteristics of DC machine under various loading conditions, determine the critical field resistance and speed of the DC shunt generator using open circuit characteristics, examine the performance of DC shunt machine with the different speed control techniques and predetermine the efficiency, estimate and separate the core losses in DC machine by conducting a suitable test, examine the performance and speed control of DC machines using simulation tools. Coming to the numericals regarding torque expressions and shaft torque, useful torque, whatever it may be. First problem, a 4-pole wave-wound DC series motor has 944 wave-connected armature conductors. At a certain load, the flux per pole is 34.6 milliwebers and the total mechanical torque developed is 209 Newton meters, 209 Newton meters. Calculate the line current taken by the motor and the speed at which it will run with an applied voltage of 500 volts. Total motor resistance is 3 ohms. So, coming to the solution. So, the given torque developed, mechanical torque developed as 209 Newton meters and flux per pole is given as 34.6 milliwebers and given the total armature conductors are 944 and since it is a wave wound, the number of parallel paths A equal to 2 and given number of poles are 4. So we have generalized expression for torque, mechanical torque developed as 0.59 5ZIA into P by A Newton meters. So this is the expression for torque. So we have some parameters like number of poles, armature conductors, flux per pole, torque developed. And also given applied voltage, we need to calculate at this voltage the speed, new speed, and also given the total resistance as 3 volts. So we substitute the given values like torque, phi, Z, P, A, everything. After substituting, we have the armature current as 20.1 amps. And substitute this armature current value in the EB value. So for a DC motor, we have voltage relation between voltage and back EMF as EB equal to V minus IARE. So after substituting all these values, we have 439.7 volts is the back EMF developed. So and also we know the back EMF formula in terms of phi ZN everything. EB equal to phi ZN by 60 into P by A. So EB we have EB value as 439.7 And after substituting 439.7 as EB and remaining all the parameters, we'll get the speed value, new speed, as 6.73 RPS or 6.73 into 60 RPM, which is nothing but 382.2 RPM. Second problem. A 230 volt shunt motor delivers 30 HP at the shaft at 1120 RPM. If the motor has an efficiency of 87% at this load, determine the total input power, the total line current. So here given a 230 volt shunt motor delivering 30 HP at 1120 RPM only. So it has efficiency, given efficiency as 87%. We know efficiency equal to commercial efficiency or normal efficiency equal to output power by input power. So if you want to express this as a percentage, so efficiency percentage equal to output by input into 100. So given output power as 30 HP, so 1 HP equal to, we know, 746 watts. So here given 30 HP means 30 into 1 HP 746 equal to, and divided by given 87% as efficiency, we will get the input power. So the input power equal to 25.70 kilowatt. And second bit, the total line current. So already given the voltage as 230 volts, we can calculate the easily line current, because P input power equal to V into IL, లేదా VT into IT. Hence, I equal to P by V, which is already P, we have calculated 27.70 kilowatt into by V as 230 volts. So we'll get 111.82 amps as a load current, line current. So this is another problem. And one more problem. A 230 volts DC shunt motor has an armature resistance of 0.5 ohms and field resistance of 115 volts. At no load, the speed is 1200 RPM and the armature current is 2.5 amps. On application of rated load, the speed drops to 1120 RPM from 1200 RPM. So determine the line current and power input when the motor delivers rated speed. So coming to the solution, first we will see that what data is given. The voltage V is given and armature resistance 0.5 ohms as given. And the field resistance, shunt motor CCT, shunt motor is field resistance RSH is given. And at no load, the speed 1200 RPM is given. And armature current 2.5 amps is given. And at application of rated load, the speed is reduced from 1200 RPM to 1120 RPM. So this is another speed. So we need to determine the line current and power input. So first, let N1 be the first speed at no load. It is running at 1200 RPM. And in this condition, at this speed, the back EMF produced as EB equal to V minus IARE. So given EB equal to V, already given 230, IA 2.5 amps, RA 0.5 volts. So its value is 228.75 volts. And at reduced speed, when the application of rated load, the speed is 1120 RPM, and at that time the back EMF equal to EB equal to V minus IARA, but in this we don't know the value of IA in this at this speed, so we need to calculate this IA. So we have a relationship between EB and speed. So back EMF is directly proportional to speed. So EB1 by EB2 equal to proportional to N1 by N2. or N2 by N1 equal to EB2 by EB1. From this N2 by N1, so second at speed at rated load is 1120 and the speed at full rated no load is 1200. So N2 by N1 equal to, we have already EB1 as 228.75 and EB2 we don't know the value of IA2 but we need to calculate this IA2, that is 230 minus EB minus IARE, IA2 RA. So from this we can calculate IA2 as 33 amps and now the total current, line current drawn by the motor equal to armature current plus and field current. So IL equal to IA plus ISH. So IA2 is 33 and ISH is, we can calculate ISH as V by RSH. V is given as 230 and RSH is given as 115. So it is 2 amps. 2 amps. So 33 plus 2, 35 amps is the line current. And power input at rated speed, rated load is nothing but V into IA, V into IL, VL into IL, which is nothing but V is 230 and IL is 235. So its value is 8050 watts. Power input at rated load is 8050 watts. And one more problem related to the same DC motors torque expression. A DC motor takes an armature current of 110 amps at 480 volts. The armature circuit resistance is given as 0.2 ohms. The machine has 6 poles and the armature is lap connected with 864 conductors. The flux per pole is 0.05 webers. Calculate first the speed and second the gross torque developed by the armature. So coming to the data in this problem, the armature current is given as 110 amps and the voltage is given as 480 volts. And armature resistance is 0.2 ohms and it has 6 poles and it is lap connected and Z equal to our total armature conductors are 864 and flux per pole pi is given, number of poles P is given, armature resistance RA is given, it is lap connected since A equal to P. We need to calculate the speed and second one torque developed by the armature. So we have an expression for back EMF as VB equal to V minus IARE. V is given as 480 volts and IA is 110 and RA is 0.2. So its value is 458 volts. And flux is given as 0.05 webers. Armature conductors are 864. And we have the expression EB in terms of phi, Z and N is phi Z by 60 into P by A, or we have EB value just now calculated, EB value calculated as 458 and EB equal to 0.05 into 864 into N by 60 into 6 by 6 A equal to P. So speed, we can calculate the speed from the data is 636 revolutions per minute. And now we can substitute this value in torque expression as, we have torque expression as phi 0.159 into phi ZIA to P by A. So 0.159 into phi into Z into IA into P by A. So 0.195 flux per pole is given as 0.05 and Z value is given as 864 and IA is 110 and P equal to A here. So A and P gets cancelled. So this torque expression, torque value is calculated as 756.3 Newton meters. So next problem, a 25 kilowatts, 200 volts DC shunt generator has armature and field resistances of 0.06 ohms and 100 ohms respectively. Determine the total armature power developed when working as a generator delivering 25 kilowatt output and as a motor taking 25 kilowatt input. First we will calculate as a generator. First For a generator, the output current is given as output current can be calculated as P by V equal to I. So given P equal to 25 kilowatt and voltage equal to 250 volts. So it is 100 amps. And already ISH is given. ISH equal to P by V by RSH. So that is nothing but 2.5 amps. And IA is given as 102.5 amps. And EMF is equal to V plus IARE for generator. So after substituting all these values, we have EG value as 256.15 volts. On power developed in armature, we have EB into IA. So it is nothing but 2.25 kilowatt. And as a motor, we can calculate the motor input current as 100 amps. ISH is 2.5 amps and IA equal to 97.5 amps. And we have EB equal to V minus IARE. Of substituting all the values, we have EB value as 244.15 volts and power developed equal to EBIA, which is nothing but EB 244.15 into 97.5 in watts, and by dividing that value with 1000, we will have the power developed armature as 23.8 kilowatt. So this is all about the torque expression problems. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.